Hello students, today we shall see center of curvature, circle of curvature, evolute and involute, etc. What is center of curvature? If rho is the radius of curvature at a point capital P of a plane curve and C is the point on the normal to the curve at P at a distance rho from the point P and on concave side of the curve. P is a point on the normal on the concave side of the curve at a distance rho from the point of contact P. Then this point C is called the center of curvature of the curve at the point P. The circle with center C and radius rho is called the circle of curvature of the curve at the point P. So this is center of curvature and circle of curvature definition. If first bracket x bar comma y bar are the coordinates of the center of curvature of a curve at a point P at which the radius of curvature is rho, then the equation to the circle of curvature is x minus x bar square plus y minus y bar square equal to rho square. Center x bar y bar, radius rho. So this is equation of circle and this is called equation of circle of curvature. The locus of the center of curvature of a curve is called its evolute. If we change the position of the point P, then the position of center of curvature will change. So that's why locus word comes. The locus of the center of curvature of a curve is called its evolute, and the curve itself is called involute of its evolute. So let us find formula for center of curvature, Cartesian formula. Let capital C with coordinates x bar comma y bar be the center of curvature of a curve y equal to fx in the xy plane. At the point Pxy, C x bar y bar is the center of curvature of the curve y equal to fx at the point P. This point P is considered. At this point radius of curvature rho, and this is normal. Cp is normal. C is at a distance rho from P on the concave side of the curve, means here circle, concave side of the curve, and this is the center of curvature. So coordinates x bar y bar assumed, and also we assume the tangent to the curve at the point P makes an angle psi with positive direction of x-axis. This is psi. Then we know dy by dx is tan psi, and dy by dx is generally written as y1. Therefore tan psi is y1 means sin psi will be y1 by root over 1 plus y1 square, cos psi will be 1 by root over 1 plus y1 square. Tan psi y1, that's why sin psi is y1 by root over 1 plus y1 square, cos psi is 1 by root over 1 plus y1 square. Very obvious from simple formula of trigonometry. Now let PL and CM are perpendiculars on x-axis, PL and CM, and PN is perpendicular on CM as in figure. Then this angle NCP is also psi. Psi is the angle made by tangent to the curve at P with positive direction of x-axis. Then this angle is also psi from simple geometry. Or you can say that angle between two lines equal to angle between their perpendiculars. Here CP is perpendicular to this tangent. CP is radius perpendicular to the tangent, radius of the circle, and this CM is perpendicular to x-axis. So angle between tangent and x-axis is angle between this CM and CP. That's why it is psi. Or in another way you can explain, this is psi, this is also psi, this angle will be also psi, alternate angle. So this angle will be 90 minus psi, this angle is 90 degree, and therefore this angle is again psi. Okay, now x bar, we want to find the values of x bar and y bar, coordinates of center of curvature. So x bar is OM, coordinates of C, x bar and y bar. So x bar is OM we can write as OL minus ML, OL minus ML. ML is equal to PN, ML PN equal, obviously, and OL is x because coordinates of P are x and y, so OL is x. And now what is PN? PN is, see, what is written? Pn is rho sin psi. Rho sin psi. Pn by Cp will be sin psi. So Pn is equal to Cp sin psi. Cp is rho, radius of curvature. So x bar is x minus rho sin psi. Okay. Now rho is radius of curvature. Formula is this 1 plus y1 square to the power 3 by 2 divided by y2. We know. Okay. And sin psi is already we have seen y1 by root over 1 plus y1 square. So this 1 plus y1 square to the power 3 by 2 and this 1 plus y1 square to the power half, when simplified we get just 1 plus y1 square, and here it is y1 by y2. So x bar is x minus y1 by y2 bracket 1 plus y1 square. This is the formula for x bar, x coordinate of center of curvature. Similarly, y bar is cm. From figure, y bar, what is y bar? Cm, y coordinate of c, y bar. That cm can be written as here cn plus nm, but nm is equal to pl, and cn will be rho cos psi, because this is adjacent. So what we have seen here, y bar is cn plus nm, cn is rho cos psi plus pl, and pl is y. We have written pl plus rho cos psi in the reverse order, and then pl is y, pl, because it is y coordinate of the point P. So y plus rho cos psi, and the value of rho 1 plus y1 square to the power 3 by 2 by y2, and cos psi is 1 by root over 1 plus y1 square. So when simplified we get y plus 1 by y2 bracketed, that is into 1 plus y1 square. So thus we have seen x bar is x minus y1 by y2 into 1 plus y1 square, and y bar is y plus 1 by y2 into 1 plus y1 square, where y1 is dy by dx and y2 is d square y by dx square, second derivative at the point P considered, whatever point in at which we consider the center of curvature, at which we consider the radius of curvature, etc. So this gives the formula for radius of curvature, center of curvature. Okay, Cartesian formula. Now let us solve some examples. Example number 12, in continuation with the previous lecture. Find the center of curvature and the circle of curvature at the point 3, 1 on the curve y equal to x square minus 6x plus 10. So curve is y equal to x square minus 6x plus 10. Therefore y1 means dy by dx is twice x minus 6. y2 means d square y by dx square is derivative of twice x is 2. Okay. At the point 3, 1, this is our point P this time. So y1 is 2 into 3 minus 6, 0, and y2 is just already 2. Therefore center of curvature, first bracket x bar comma y bar, this is the coordinates of center of curvature at the point 3, 1 is given by x bar is x minus y1 by y2 into 1 plus y1 square. Formula, x is here 3, because at the point 3, 1 we are finding. So 3 minus y1 is 0, so 3 minus 0 is 0, and y bar is y plus 1 by y2 into 1 plus y1 square. y1 is 0 and y2 is 2, so it is, and y is also 1, so 1 plus 1 by 2, 3 by 2. Therefore center of curvature is 3, 3 by 2, coordinates of center of curvature. Also radius of curvature at the point 3, 1 is given by rho equal to 1 plus y1 square to the power 3 by 2 by y2. So put the values of y1. y1 is 0, y2 is 2, so it is just 1 by 2, radius of curvature. Therefore the equation to the circle of curvature is given by x minus x bar square plus y minus y bar square equal to rho square. Center is x bar comma y bar and radius is rho. So this is x minus 3 square plus y minus 3 by 2 square equal to half square. Now just simplifying, we get, expanding the square, side changing, etc., we get 9 by 4 minus 1 by 4 is 8 by 4 is 2. So this 2 and this 9 gives us 11. So x square plus y square minus 6x minus 3y plus 11 is 0. This is equation to the circle of curvature at the point P. Okay. Sorry. Example 13. Find the circle of curvature of the following curves at the indicated point. First curve is x cube plus y cube equal to thrice axy at the point thrice a by 2 comma thrice a by 2. At this point we have to find the equation to the circle of curvature. For this we need to find the coordinates of the center of curvature and the radius of curvature. Second one is root x plus root a equal to root a at a by 4 comma b by 4. This number 2 will be left as an exercise you will do, similar to Roman 1. 3, 4 will be also done. Number 3 is given in parametric form. X equal to e to the power minus twice t cos twice t, y equal to e to the power minus twice t sin twice t at the point t equal to 0. And number 4 is y square equal to 4x at the extremity of lateral rectum in first quadrant. So first Roman 1 we see x cube plus y cube equal to thrice axy. Differentiating with respect to x, this line we get 3x square plus 3a square into dy by dx then 3a into x into dy by dx plus 1 into y, because derivative of x is 1. 3 cancels, x square plus y square dy by dx equal to a into x into dy by dx plus y. This is line number 1. Differentiating this line again with respect to x, we get 2x, and y square is 2y into dy by dx. Already there is a dy by dx, so it is dy by dx square plus y square remains dy by dx, derivative of dy by dx is d square by dx square, equal to a into x into dy by dx, u into v rule, x into derivative of dy by dx is d square by dx square, plus x remains derivative of x remains derivative of dy by dx is d square by dx square. Done. Now dy by dx remains, derivative of x is 1, so 1 dy by dx, and another y means you have to differentiate, it will be dy by dx, so dy by dx plus dy by dx means 2 dy by dx written directly. Okay, here 2 dy by dx written directly. Then at the point 3a by 2 comma 3a by 2, we need dy by dx and d square by dx square. So that is when x equal to 3a by 2 and y equal to 3a by 2 we get from 1 and 2. In line number 1, if we put x equal to 3a by 2, y equal to 3a by 2, we get this 3a by 2 square, 3a by 2 square, dy by dx plus a into 3a by 2 dy by dx plus 3a by 2. Okay, now 3a by 2 gets cancelled from both sides. So 3a by 2 plus 3a by 2 dy by dx equal to a into dy by dx plus 1. Then a will be also cancelled. So we get 3 by 2 plus 3 by 2 dy dx equal to dy by dx plus 1. Now just side change. 3 by 2 minus 1 will be half dy by dx, and this 3 by 2 when minus 1 minus 3 by 2 is minus half. So dy by dx is minus 1. That means y1 equal to minus 1. First derivative, y1 is minus 1. Now also putting x equal to 3 by 2, y equal to 3 by 2 in line number 2. Here if we put, we shall get d square by dx square. So what we get, just putting 2 into 3a by 2 plus 2 into 3a by 2 into dy by dx square, but dy by dx we have got is minus 1, so minus 1 square plus y square into means 3a by 2 square into d square by dx square equal to a into x into d square by dx square. So x means 3a by 2 plus 2 into dy by dx is minus 1 we got. Okay, in line number 3. Now 3a by 2, not 3 by 2, these two cancels, these two cancels, and a 1a will be cancelled. So 3 plus 3 here, it will be 9. A square means 1a gets cancelled, so 9a by 4 d square by dx square equal to thrice a by 2 d square by dx square minus 2. Now it is 3 plus 3 6, when side change minus 8 it becomes, and 9a by 4 minus 3a by 2, we can consider it as 6a by 4. So 9 minus 6 is 3, 3a by 4 d square by dx square is minus 8. So d square by dx square is minus 4 into 8, 32 by 3a, or y2 second derivative is minus 32 by 3a. Therefore radius of curvature of the curve at 3a by 2 comma 3 by 2 is rho equal to 1 plus dy by dx square to the power 3 by 2 by d square by dx square. Formula, just put the values 1 plus minus y1 square minus 1 square, because dy by dx is minus 1 to the power 3 by 2 and d square by dx square is minus 32 by 3a. So just this is 2 to the power 3 by 2 means 2 root 2, and this becomes minus 3a by 32 reciprocal. So minus 3 root 2 a by 16, but rho is measured positive, radius of curvature by convention, so rho equal to 3 root 2 by 16a. The center of curvature x bar y bar of the curve at 3 by 2 comma 3 by 2 is given by x bar equal to formula x minus y1 by y2 root into 1 plus y1 square. Put the value of x means here 3a by 2, y1 by y2, y1 is minus 1, so this becomes plus, and y2 is also with negative sign minus 32 by 3, so ultimately it remains minus 3a by 32. Okay, and 1 minus 1 square is 1, so it is 1 plus 1. Finally it is thrice a by 2 common 1, and here it is 16 minus 3 by 2 32 cancelling, it will be 16, and another 2 taken common, so it will be 8. Okay, 1 minus 1 by 8 means 7 minus 7 minus 8 minus 1, 7 by 8 means 16, 21 by 16a. Okay, then y bar is 1 plus y plus 1 by y2 1 plus y1 square, y is 3a by 2 and 1 by y2 is minus 3a by 32, because y2 was 32 by 3a with a minus sign, and this y1 square is 1 actually, that's why it is 2. So again 3a by 2 minus 3a by 16 means finally similar to previous one, 21 by 16a. So x bar y bar obtained means center of curvature we have got. Therefore circle of curvature is, means equation to the circle of curvature is x minus x bar square plus y minus y bar square equal to rho square, radius of curvature square. So putting the values of x bar and y bar, both 21 by 16a, 21 by 16a, and rho is 3 root 2 by 16a, square is there. So finally it is root 2 square 2, it will become 16 into 16, so 8 into 16, 128, 9 by 128 square. Okay, so this is the equation to the circle of curvature at the point 3 by 2 comma 3 by 2 as per question. Okay, Roman 3, Roman 2 left as an exercise similar to Roman 1. Roman 3 in parametric form, x is e to the power minus twice t cos t, y is e to the power minus twice t sin t. So let us find x dash. X dash means here dx by dt. E to the power minus twice t derivative is minus 2 e to the power minus twice t cos twice t remains, plus e to the power minus twice t remains, cos twice t derivative is minus 2 sin twice t. So take minus common, to e to 2 common, e to the power minus twice t common, so it is cos twice t plus sin twice t. Then x double dash d square x by dt square, second derivative. So e to the power minus twice t derivative is again minus 2 into e to the power minus twice t, so it becomes 4. Cos twice t plus sin twice t remains. Then minus 2 e to the power minus twice t remains. Derivative of cos twice t is minus 2 sin twice t. Sin twice t is 2 cos twice t. Okay, we have calculated. Now question is, we have to find circle of curvature at the point t equal to 0. So when t equal to 0, x, what is x? X is e to the power 0 cos 0. E to the power 0 cos 0 is 1. X dash, this is x dash. When t is 0, so it is minus 2 e to the power 0 and cos 0 plus sin 0. Sin 0 is 0, cos 0 is 1, so it is minus 2 x dash. Then x double dash, it is 4 e to the power 0 means 4 and cos 0 is 1, so 1, sin 0 is 0, so 0 minus 2 e to the power 0 is 1, sin 0 is 0, cos 0 is 1, so again it is 4 minus 4, 0, so x double dash 0. Now we see y dash. Y is e to the power minus twice t sin twice t, so y dash is dy by dt as before. E to the power minus twice t derivative is minus 2 into e to the power minus twice t sin twice t remains, plus e to the power twice t remains, sin twice t derivative is 2 cos twice t. So 2 e to the power minus twice t common, cos twice t minus sin twice t. Then y double dash d square y by dt square. Again if we differentiate, e to the power minus twice t derivative is minus 2 e to the power minus twice t means minus 4 e to the power minus twice t, cos twice t minus sin twice t remains, plus 2 e to the power minus twice t remains, cos twice t derivative is minus 2 sin twice t and sin twice t derivative is 2 cos twice t. Okay, now when t equal to 0 as before, y is e to the power 0 sin 0, sin 0 is 0, so y is 0. Y dash is this here, 2 e to the power 0 means 2 into 1, here cos 0 is 1, 1 minus 0. Okay, so it is 2. Y double dash is here, minus 4 into e to the power 0 1, cos 0 is 1, minus sin 0 is 0, so 1 minus 0. Then 2 e to the power 0 means 2 and sin 0 is 0 minus cos 0 is 1, so it is minus 2. Finally minus 4 minus 4 minus 8. So point corresponding to t equal to 0 is actually x is 1, y is 0, so 1 comma 0. Therefore radius of curvature at t equal to 0 is formula, parametric formula is this: rho equal to x dash square plus y dash square to the power 3 by 2, x dash y double dash minus x double dash y dash. Values of x dash square, y dash square. X dash is minus 2, y dash is 2, so when we square both becomes 4, 4 plus 4 to the power 3 by 2. X dash is minus 2, y double dash is minus 8 and x double dash is perhaps 0. We have seen already x double dash is 0. Okay, so 0. So finally it is 4 plus 4, 8 to the power 3 by 2 means 8 root 2, and here it is 2 into 8. This 8 cancels, root 8 means 2 root 2, 2 cancels, so root 2. Radius of curvature is root 2. Now we need y1, dy by dx. Y1 is dy by dx is y dash by x dash. So value of y dash and x dash divided, 2 e to the power minus twice t gets cancelled, with a minus sign we get this expression. When t is 0, we get 1 minus 0 by 1 plus 0 with a minus sign, so it is minus 1. Y2 is ddx of dy by dx, d square y by dx square. So it is ddt of ddt of y dash by x dash, because y1 is y dash by x dash, into dt by dx. It was ddx, we have differentiated with respect to t, and then with dt into dt by dx by chain rule. But dt by dx is what? 1 by dx by dt, so it is 1 by x dash. Okay, and here u by v rule we have applied. X dash square, x dash into derivative of numerator means y dash, derivative is y double dash, minus y dash remains, derivative of denominator is x double dash. Here derivative with respect to t. but all the values we have calculated at t equal to 0. So here x double dash is minus 2, y double dash is minus 8, and x double dash was 0 at t equal to 0, so it is 0, and x dash cube, x dash was minus 2, so minus 2 cube. Finally it is minus 2 cube is minus 8, so minus 8, and this minus 8 will go, minus 2 will remain. The center of curvature x bar comma y bar of the curve at t equal to 0. That means at x equal to 1 and y equal to 0. T0 gives us x equal to 1, y equal to 0, already we have seen. So x bar is x minus y1 by y2 into 1 plus y1 square. Y bar is y plus 1 by y2, 1 plus y1 square. Formula. Now x is 1, so 1 minus y1 by y2 is y1 we have calculated minus 1, and y2 is minus 2. So it is y1 by y2 is half into 1 plus y1 square means again 1, so it is 0. And y bar is, y is 0, when t is 0, y is 0, so 0 plus 1 by y2, y2 is minus 2, so 1 by minus 2, 1 plus 1, because y1 square is 1, so it is minus 1. Therefore circle of curvature, center of curvature we have got what? 0 comma minus 1. Therefore circle of curvature is given by x minus x bar square plus y minus y bar square equal to rho square. So x minus 0 square plus y minus minus 1 means plus 1 whole thing square equal to root 2 square. So it is x square plus y square plus 2y plus 1 minus 2 means minus 1 0. Okay, so this is y square equal to Roman 4, y square equal to 4x. Last one, y square equal to 4x. We have to find the radius of curvature at the point 1 comma 2. Extremity of lateral rectum of this parabola is in first quadrant is 1 comma 2, because length of lateral rectum of this parabola is 4a, means here 4, above is 2, below is 2, so 2, y coordinate will be 2, and focus is a comma 0 means 1 comma 0, because a is here 1 for this parabola, so 1 comma 2. So differentiating number 1 with respect to x, we get dy by 2y dy by dx equal to 4 implies dy by dx equal to 2 by y, and d square by dx is 2 by y, derivative is minus 2 by y square into dy by dx. And then at the point 1 comma 2, because this is the end point or extremity of the lateral rectum, in the first quadrant is 1 comma 2, in the fourth quadrant it is 1 comma minus 2. So we need at 1 comma 2, y1 is dy by dx means 2 by 2, 1, y2 is d square by dx square is minus 2 by 2 square into 1, d square by dx square is dy by dx is below 1 already, so minus half. Therefore radius of curvature at the point 1 comma 2 is rho equal to, formula we have ready made, 1 plus y1 square to the power 3 by 2 in by y2, so 1 plus 1 to the power 3 by 2 by minus half, y2 is minus half, finally it is minus 4 root 2, because this is 2 to the power 3 by 2 means 2 root 2, so it will be 4 root 2, but rho is measured positive, so rho equal to 4 root 2. The center of curvature x bar comma y bar of the parabola at 1 comma 2 is given by x bar equal to, by formula, x minus y1 by y2 into 1 plus y1 square, y bar is y plus 1 by y2 into 1 plus y1 square. So putting the values here, point is 1 comma 2, so x is 1 and y is 2, so 1 minus y1 by y2 and 1 plus y1 square value. So y1 by y2 we have substituted, y1 is 1, y2 is minus, means it will be 2 y1 by y2, but minus is already there, so plus 2 into 1 plus 1 means 5, and here it is 1 by y2 means minus 2, because y2 was minus half, 1 plus 1, so it is finally 2 minus 4 means minus 2. Therefore circle of curvature, that is equation to the circle of curvature, is x minus x bar square plus y minus y bar square equal to rho square, and values of x bar y bar is 5 and 2, y bar is minus 2, so that's why minus minus plus 2 square. Now just square, breaking square, step changing, we get x square plus y square minus 10x plus 4y minus 3 equal to 0. It will be 16 4 root 2 square, it will be 2 and 16 32, and here it will be 25 and 4, that is 29, so 32, 29 minus 32 is minus 3. Okay, so this is equation to the circle of curvature. Example 14, the last example. Prove that the evolute of the hyperbola 2xy equal to s square is x plus y to the power 2 by 3 minus x minus y to the power 2 by 3 equal to twice a to the power 2 by 3. Evolute means locus of the center of curvature. Locus of the center of curvature of the hyperbola. This hyperbola, this is rectangular hyperbola, is that. So first we shall have to find the center of curvature. So curve is, means parabola, hyperbola is 2xy equal to s square, that is xy equal to s square by 2. So differentiating with respect to x, we get x into dy by dx plus y equal to 0. S square by 2 is constant. So dy by dx is minus y by x. Now differentiate this line again with respect to x. What do you get? D square by dx square, right side is u by v. So v square means x square, v into du by dx means here u is y, dy by dx minus y into derivative of x is 1. Now put the value of dy by dx from line number 2, it is minus y by x. So x cancels, minus y minus 2y, but there is a minus sign, so it will be 2y by x square. So we have calculated. The center of curvature x bar y bar of the hyperbola at any point xy is given by. This time we have to find the locus of the center of curvature. That's why we are considering radius of curvature, center of curvature at any point xy. So it is given by x bar is x minus yn by y2 1 plus yn square, y bar is y plus 1 by y2 1 plus yn square. Now putting the values of y1 and y2, we get what? X plus x by 2, y1 by y2, you can check. It is 1 plus y1 square means y by square by x square. Similarly 1 by y2 value, this is x square by 2y, y2 was 2y by x square. That's why y2 means d square by dx square, y1 means dy by dx. Okay, and then x square by 2y into 1 and x square by 2y into x square by 2x, we cancel, we get what we get? X square cancels, we get y by 2y, y by 2y, and that y, when y by 2, x square by 2y into y square by x square, if we multiply, what we shall get? We shall get y by 2, and there is a y, so half y and y, 3 by 2y written, and x square by 2y written. Similarly here x by 2 1 and x means it is 3 by 2x, and here simplifying we get y square by this x square cancelling, it is y square by 2x. Okay, now answer is given. Locus is x plus y to the power 2 by 3 minus x minus y to the power 2 by 3 equal to twice y to the power 2 by 2. So let us calculate x bar plus y bar and x bar minus y bar first. So we have calculated x bar plus y bar, values of x bar y bar added. Taken LCM 1 by 2s xy, got this. This is a plus b whole thing cube formula, means x plus y whole thing cube, and 2xy is s square because xy is any point on the curve number 1. 2xy is s square, and x bar minus y bar, again we have simplified, taken LCM, we have got this is a cube minus thrice a square b plus thrice a b square minus b cube, like that. So it is a minus b whole thing cube formula, means here it is y minus x whole thing cube, but can be written as taking minus common, x minus y whole thing cube, and denominator is 2xy, means it is s square using line number 1. So x bar plus y bar to the power 2 by 3 minus x bar minus y bar to the power 2 by 3 is what? It will be x plus y to the power 2 by 3, means it will be square, and it will be 4 by 3. Okay, 1 by a to the power 4 by 3, x plus y to the power 2, minus here x bar minus y bar to the power 2 by 3 will give us a to the power square 2 to the power 2 by 3 will give us a to the power 4 by 3, and x minus y to the power 3, to make it we raise it to the power 2 by 3, it will be square. Okay, and then taking 1 by 8 to the power 4 by 3 common, what we get? X plus y whole thing square minus x minus y whole thing square. Okay, if we square it, 2 by 3 means if we square it, this minus sign will go. That's why this is minus sign, this minus sign is there. It is already minus, this minus sign is there, you can see, but when we make it, raise it to the power 2 by 3, it will become plus. That's why here it is 1 by a to the power 4 by 3, x minus y to the power 2, but this minus sign is that minus sign, whatever given. So a plus b whole square minus a minus b whole square is 4ab, we know, so it is 4xy here, but 2xy is s square using line number 1, so 2 into 2xy, so we have written is 2s square, 2s square by 4, a to the power 4 by 3, so it is 2 into a to the power 2 minus 4 by 3 means 6 minus 4, that is 2 by 3. So what we have got? X bar plus y bar to the power 2 by 3 minus x bar minus y bar to the power 2 by 3 is twice a to the power 2 by 3. So locus of x bar y bar, we want to find locus of the center of curvature x bar y bar is replacing x bar by x and y bar by y. Locus of a point, if it is x on y, you replace by x and y. If it is h and k, replace h and k by x and y. So here locus of x bar y bar means center of curvature, so we replace x bar by x, y bar by y, so we get this equation, and this was given in the question. We have to show that or prove that this is the locus of the center of curvature. This is locus of center of curvature, and this is known as evolute. So this is evolute of the hyperbola given. Okay, thank you for this chapter today.